Welcome to the Energy Central Power Perspectives podcast. This is a show that brings leading minds from the energy industry to discuss the challenges and trends that are transforming and modernizing our energy system. And a quick thank you to Power Engineers, our sponsor of today's show. Now, let's talk energy. I'm Jason Price, Energy Central podcast host and director with West Monroe, coming to you from New York City. And with me, as always, from Orlando, Florida, is Energy Central producer and community manager, Matt Chester. Matt, today's episode is focused on a unique angle of the energy workforce, which is engineering, not just to decarbonize, also to address air pollutants related to energy generation. Environmental responsibility extends beyond just staving off climate change, but also in the everyday health and safety associated with the power sector. So Matt, when it comes to the state of air pollutant regulation and requirements of the utility industry, what are the standard protocols that U.S. power companies are working under these days?
Yeah, hi, Jason. And I'm definitely not the expert on this, and perhaps our guest who is the expert can expand further. But, I can share that for all utilities, it does pretty much boil down to the starting point of the Clean Air Act from the U.S. Environmental Protection Agency, who set limits on air pollutants coming from utilities as well as industrial sources like chemical plants, steel mills. And Congress passed the Clean Air Act in 1970, and that bestowed EPA with the regulating authority covering all sorts of different pollutants that were known then and that have since become familiar. So from the type of localized pollutants that cause direct health issues or covering risks from ozone depletion to toxic air pollution, and then eventually expanded to climate changing greenhouse gases. It all kind of comes back to that.
Well, thanks for that, Matt. This is definitely a critical topic, and we're eager to get more of an inside look into the environmental engineering side of the power sector. And that's why we're bringing in today's guest to the podcast. Tom Rolfson is the project manager at Power Engineers, a company specializing in the delivery of integrated energy solutions with expertise in the engineering, infrastructure, and programs needed to meet utility-wide goals. Tom specifically works with a team of environmental engineers in the world of air quality permitting and regulatory compliance, so he has a unique vantage point to share. So without further ado, let's bring him in. Tom Rolfson, welcome to the Energy Central Power Perspectives podcast.
Hi, Jason. Glad to be here today.
As are we. So, Tom, our Energy Central audience might have seen you around the community before as part of our network of experts. But for those who are unfamiliar, can you share a bit about your background and the work you do with the Power Engineers team?
Sure. So as many of us do at Power Engineers, I wear a number of different hats. As you mentioned, I'm a project manager. I'm also a department manager for a team of air quality and environmental professionals, but I'm still an engineer. I work on projects from a technical standpoint as well as project management, and I'm in our air quality practice, which is within our larger environmental division. And to put it somewhat concisely, we help our clients, large and small, comply with various environmental regulations, primarily as they pertain to air emissions. Pre-permitting, feasibility studies, actual permitting, ongoing compliance with permit conditions, navigating regulatory requirements, new or old, and just overall assistance in anything that has to do with air emissions is really what we do. Our clients range from some of the largest power plants in the country today and power plant developers for these types of plants down to very small facilities. Think local regional hospitals and colleges with maybe just a couple of packaged boilers and some emergency generators, covering just about everything in between.
Tom, I imagine environmental engineering was not always a main driver of engineering energy generation projects and the approach of Power Engineers, but instead, this has come about over time. So can you talk about this transition and how have you seen the role of environmental engineers in this context change over the course of your career?
Well, in my relatively brief career, one thing that I've really seen continue to come to the forefront are the various levels of public involvement. And these can really make or break a project. And a lot of this involvement is related to environmental concerns. Sometimes this means that regulatory agencies will act a bit preemptively with that in mind. The public doesn't even have to get involved for that aspect to affect a project. The permit may be written very conservatively to avoid potential issues down the road. And can a facility live with that in their permit? And of course, when the public does get involved, you really have to be on your game. Comments are made, they have to be responded to, questions are asked, and additional information and significant justification in many times really needs to be made. So with all that said, environmental engineers have increasingly had to conduct more and more studies to support these permitting and post-permitting project efforts. There's a growing number of projects that are now being denied permits due to environmental issues. There's also a very high number of projects that might get permitted, but they never get built. And this is due to a variety of factors, some involving public involvement, where a permit may be appealed and a long drawn-out legal process might take place that essentially delays financing for a project, which eventually kills it. There's other real concerns out there with, environmental justice and environmental, social, and governance, otherwise known as ESG, is now becoming a major factor in project finances. The financing of projects largely hinges on these environmental factors. So we are seeing project owners start to pull in environmental teams earlier. As I mentioned, we do a lot of pre-permitting feasibility studies. Before you start to work on a project, it really behooves you to know if you're going to be able to get those permits and what you may have to do on top of what you were already thinking to get those permits. And often cases we'll do air pollution dispersion modeling before we really have the solid project data, just to know what are we going to run into when this project starts to be developed. We develop a variety of permit matrices where we outline every single environmental permit that a project is going to need to obtain and how long it's going to take, what the roadblocks are there any fatal flaws, what's it going to cost? These are all important considerations. And of course, there's, as I mentioned, a variety of regulatory assessments, whether there are new regulations, existing regulations, project modifications that will trigger another regulation to become applicable. We are really seeing environmental concerns come in early to these projects and often.
Yeah, no doubt. And I'm sure that, decarbonization is the lowest common denominator. That's, first of all, what is the footprint of GHG in any investment that's being made? So, given your role as an environmental engineering expert, you're looking at, the decarbonization side of the equation, but there's more to it. And you alluded to some of them, the equity side. There might be a community benefit side. But can you go a little bit deeper in that? Can you share with our audience, when you're looking at projects from the beginning, the get-go, and they're pulling you in at the start, it sounds like, can you share with our audience what some of those benefits are that the team should be thinking about when evaluating such investments, especially, beyond just the decarbonization requirements?
Yeah, decarbonization is obviously a very huge topic and covers a lot of different technologies and actions that companies can take. And from an environmental permitting perspective, there's a lot more that's involved than just carbon emissions. And we look at all pollutants that are emitted from a certain source, and oftentimes those other pollutants are what drive the permitting actions from a regulatory standpoint. And when we talk about decarbonization in, a classical sense of, say, converting a coal-fired power plant to burn natural gas, there are tremendous benefits to decarbonizing in kind of the simple scenario like that really have nothing to do with climate change benefits. The reduction in the other pollutants, that comes from not just the coal to oil or coal to gas conversions, but also in the influx of renewables as opposed to some of the traditional fossil sources. NO2, nitrogen dioxide, is a significant pollutant that causes a lot of health issues, a lot of respiratory issues, asthma. I think researchers at George Washington University had conducted a study that came up with the result that nearly 13% of all pediatric asthma is linked to NO2 pollution. That's 4 million children globally each year that develop asthma from exposure to NO2. That's a huge number. Obviously, the major cities have the highest rates of this health impact, and a lot of that is due to traffic, not power plants necessarily. But again, decarbonizing traffic emissions is going to result in lower NO2 emissions. And we're also seeing higher results of pediatric asthma in countries that do burn more coal. There's, significantly more pollution in those areas. NO2 also causes other environmental issues: acid rain, haze and smog, nutrient pollution in coastal waters. So lowering NO2 emissions is one of the things we see the most in project permitting efforts. How low can you get your NO2 emissions? They're above certain thresholds. You really need to apply emission controls and pay for offsets and things like this. typically the higher carbon emitting fuel sources are also higher NO2 emitting fuel sources. NO2 is also a precursor to lower atmospheric ozone. That's the bad ozone. The ozone in the upper atmosphere is protective of the planet from some of those harmful UV rays, but the lower atmospheric ozone is that which causes respiratory issues and smog. And to kind of reiterate that simple example, replacing a coal plant with a natural gas plant is a huge improvement from an NO2 emission standpoint. And that is just one pollutant of many emitted from combustion sources. We have sulfur dioxide, which in large part has gone down significantly with the desulfurization of a lot of fuel sources. But again, that is a major acid rain and acid deposition problem. The particulate matter emitted from some of these combustion sources is also of significant concern. Does anybody ever really not move when they're in the campfire ring when the smoke starts hitting them in the face? No, everybody wants to get out of that smoke zone. And that may be kind of an extreme example of particulate matter emissions. That is what we're referencing there. And of course, there's a variety of other harmful pollutants, mercury, other toxic pollutants, heavy metals. These are generally all reduced with a reduction in CO2 emissions, with decarbonization efforts. Now, are there some environmental downsides to cleaner and greener technologies? There are a few. There is a balancing act here, but we need to think about what we're doing in a vacuum. This all brings to mind a quote from one of your previous podcast guests, Mike Richter, the president of Brightcore Energy and Stanley Cup champion, that we shouldn't be green for green's sake, but we should be green for humanity's sake. Not just the decarbonization efforts for climate change, but the decarbonization and reduced emissions efforts that we're making are going to have benefits far beyond climate change and will have an actual impact on human health.
Well, I appreciate that. You're not the first, obviously. You're not going to be the last guest talking about, moving from coal to natural gas. That's considered a win and then continue moving in a cleaner direction. But there's no shortage of insiders who really understand how the system works. And, looking at Texas, the tornadoes and the storms, the winter storms and such, it's really gas at the end of the day is sort of saving the day. Give us your perspective, since you're seeing these big power engineering projects and you're seeing the market where the dollars are being invested. So you have somewhat of a horizon, several years out, because these projects, they take time to build. Share with us your views on the role of natural gas and the types of projects you're seeing to help further decarbonize the grid. What are you seeing?
Well, we're seeing natural gas play a very large role in that decarbonization effort. Now, that may sound contradictory to some, but again, as you mentioned, some of those of us inside the energy sector, I think, have a slightly clearer picture of that. I'm going to again refer to a previous guest. I think this was a quote from Suzanne Ogle, president of the Southern Gas Association, and she referenced what we're seeing is an energy evolution and not a transition. As we evolve towards a decarbonized future, gas has a significant role to play, even in the best case scenarios where we are installing tremendous amounts of renewables capacity. Right now, with energy storage technology where it is today, and even probably for the next couple decades, we would have to significantly overbuild renewables capacity in order to provide all of our energy needs. And we know natural gas, we know how it works very well. We can build extremely efficient and low emitting power plants to utilize this gas. And that's just looking at it domestically. Globally, there is still a lot of coal being burned. Coal is still the number one fossil fuel of choice globally. Natural gas is unequivocally more environmental friendly than coal. It's really not even worth getting into a debate about it. And of course, shifting gas away from the residential and commercial customers that we're seeing with electrification of homes and businesses is going to free up some gas supply for industrial and utility use, which is hopefully going to make it more cost competitive for the major power producers. Now, the US EIA makes lots of different energy projections. They are obviously keenly aware of the situation, and they project a large amount of natural gas-fired electric generating capacity for the next 20, 30 years. not quite as much as renewables capacity installations, but still a very significant amount. And one way to think about why this might be happening is that for every megawatt of solar or wind capacity installations, we need another megawatt of some sort of backup capacity or energy storage capacity. Because when we have those periods where either at night when the sun is, of course, not shining, or during those non-windy conditions, without enough energy storage, we really need some backup energy generation capacity. In a lot of other ways, we don't have energy storage combined with the long transmission necessary to get energy from points A to B when points A and B are 1,000 miles apart. We're coming up with a lot of different solutions to, deal with pollution from fossil fuel fired power plants. And, one of the first places to turn is natural gas as a replacement for all the other ones. And we're also still coming up with great solutions to continue to deal with the pollution from natural gas power plants. Those NO2 emissions that I referenced earlier, those are being controlled to a significant degree in these large power plants. The emission control technology out there right now is extremely refined and is constantly getting better. We've also got other technological solutions, such as like the alum FETVET cycle, which utilizes oxycombustion of natural gas, which allows for the really easy separation of CO2 from the exhaust stream. So carbon capture in a way. We're also looking at traditional carbon capture with kind of the regular old natural gas fired power plants. We're coming up with some really great ways to control the emissions from these natural gas power plants, and the natural gas power plants are already better than a lot of the other fossil fuel fired power plants that are out there.
Tom, you brought up energy storage. Are you seeing more energy storage investments in the projects you're building?
As a company, we are seeing a lot more energy storage projects. Being in the air emissions side of environmental engineering, I am personally not touching a lot of those projects because there are, of course, no real air emission sources with those projects. But listening around in other company communications, that is something that, again, in the course of my career, I'm hearing that word a lot more than I used to.
Right. A day doesn't go by where energy storage isn't sort of looked upon as potentially that saving grace of the future in terms of dispatchable type of solution, but it's still not there technology-wise, cost-wise, and so on. You sound like you've got some insight into the C-suite, so I'm going to put you on the spot if you don't mind. I'd love to hear from you. There is a degree of differences on the types of air pollutants that get regulated with carbon. So, what are some of those differences? And then as a follow-up, does that influence the investment thesis on how companies approach investments? I don't know if you could talk a little bit about that.
Your first question, what are some of the differences in how these pollutants get regulated compared to CO2? I think the biggest one that I can think of is that there's not a specific ambient air quality standard for CO2. What I mean by that is simply a limit to the concentration in the atmosphere of that pollutant. A lot of air pollution regulation for the other pollutants is based on the allowable concentration of each pollutant in the atmosphere that is protective of human health and ecosystem health. NO2, as I mentioned, has a rigorous ambient air quality standard, as do most other pollutants. CO2 does not. We are, of course, measuring the concentration of CO2 in the atmosphere, but it is not necessarily an acute human health pollutant. With that said, it is still heavily regulated. But if I'm being somewhat candid, I think most investors and approaches from the energy company with respect to CO2 is not necessarily regulatory driven. Consumers are now able to speak with their wallets, I'd say more than they probably ever have before. In a period where ESG and environmental justice have become significant players, financial entities are not going to invest in company A is producing the same product but with higher CO2 emissions than company B. I think that's a pretty well-known fact at this point. And it is so highly scrutinized that those carbon footprints, so to speak, are really becoming important for every industrial, commercial, and just about any entity out there to have a good handle on. We need to measure, we need to minimize, and really focus on what that carbon footprint is if we want to stay relevant in public spaces.
Let me ask you about innovation. So I had just gotten back from the Public Utility Fortnightly Innovation Awards ceremony and conference. And a lot of the winners for this year recognized for their innovation was really nuanced or abstract innovations that were specific to their needs. Now, I'd really love to hear from you on, do we have enough technology to start scaling, or do you think that we're still a long ways away from getting what we need? Just what is your general impression of innovation in the power engineering generation side of things?
And I'm going to come at this from what I think is a somewhat limited perspective, because most of the projects we're seeing are the ones that have made it to scale. But we do keep our eyes on some of these innovative solutions that we think are going to be coming down the pipe. We are starting to see some really innovative solutions to increasing efficiency, decreasing emissions, and getting renewables into the mix responsibly. There's a lot of really cool technologies out there that are being developed that are definitely going to help us in our clean energy goals. Traditional renewables themselves are pretty well known. I don't think it's necessarily about developing new technologies there, but constantly refining them and perfecting them. Energy storage, I think, is still evolving in a pretty major way. Whether it's novel solutions that involve certain mass transfers or the traditional battery storage where innovation is constantly being done to find that best battery. If we wanted to just keep doing the same old thing, there wouldn't really be a need to innovate. So we would just have that consistent drive to perfect. So it's kind of two prongs. There's the perfection aspect and the new technology aspect. I mentioned earlier the LM FET cycle, and that is kind of a new innovative technology. And what we're seeing is that bringing a technology like that into an older market is a lot easier said than done. Until that first full-scale plant goes online and we can really analyze its performance both mechanically, technologically, and financially, there's going to be a reluctancy to take that risk and have other investors make a move on some of that technology. So I think kind of going back to the initial question, do we have enough technology out there and we're missing the deployment of it? I would like to think that we do, and that getting that technology to scale is something we're going to really start seeing as we continue on this energy evolution.
Yeah, no doubt. And I'm certain that certainly the federal government, the IJA and IRA tax incentives and the investments will hopefully further scale some of these technologies to full deployment. So maybe we'll see that in the next.
It does all come down to money. I mean, as cynical as that will sound sometimes, can a company afford to make a certain technology at scale? Will anyone buy it if they do? There's a lot of risk involved with that, of course. And I think a lot of these tax incentives that we're seeing are out there to just help push some of that forward.
Right. So switching gears for a moment, talk about workforce challenges. As a power engineering firm, I'm sure you are facing similar, resource challenges as the rest of the industry. I mean, utilities and specifically, it's an aging workforce. They're finding it very hard to compete both from a salary standpoint and the mystique of working at, for like a tech startup or Silicon Valley is a lot more, attractive than working at a utility. So what are you seeing at Power Engineers? Are you having similar challenges? Are you seeing that, or are you doing something different that the industry can learn from?
Well, as you mentioned, we're all facing resource challenges these days. And I think part of this does tie back into that innovation topic. Nobody wants to be stuck in some boring job. I think that innovative approach is going to attract more talent. That's pretty clear. If we look at people who are wanting to go and, be an engineer at a coal plant versus, at some newer technology plant, we could probably imagine where they might turn. Now, as a consulting firm, we're also seeing an influx of younger people who are interested in helping to solve this energy problem that society is facing. And in environmental, a lot of these are coming in from a sustainability angle, where maybe there's a little less desire to do technical work, but more on the regulatory or even political side. And I think there's a bit of a mischaracterization of what we do by those that are unfamiliar with the business, and they don't see what we do as being cutting edge or highly innovative. And that's not really correct. I mean, we do touch a lot of those projects. We might not dive as deep into them as, say, the company who is manufacturing some highly innovative piece of technology. But we get involved in certain ways that allow us to see a broad spectrum of these things, which is really neat. I've gotten to dive into technical details of some of the most advanced power generating sources. I get the opportunity to research new technologies, whether it's for an actual project, for a client, or for marketing purposes and developing, an article or a paper to get Power Engineers' name out there further. And the other disciplines at Power Engineers, while I am not intimately involved with what they do, they are definitely working at the forefront of innovation as it relates to energy generation and delivery. The mechanical, electrical, and civil engineers at our firm are involved, again, with some of the most innovative projects in the country and around the world. And for the prospective employees that we're looking for, it's hard to know that just looking at a company. And until you get into it, it can be a little more difficult, I would say, to really know where you're going to be in a couple of years as you're filling out that application. So we're trying to also be innovative about how we bring in those new resources and to make sure that they know what it is we really do and how they can fit in and how they really have no limits to what they might face in their career.
Absolutely. And you're no doubt an important voice to power engineers in the field. So, again, we're thrilled to have you on. We're going to give you the last word, but first we have something called the lightning round, which is where we get to learn a little bit more about you, Tom, person rather than the professional. So we have a series of questions, 5 questions, and we ask you to keep your response to one word or phrase. So are you ready?
I am ready.
All right. What is your go-to road trip snack?
Snickers bar and a Diet Coke.
Do you have any hidden talents?
I would consider some of my musical talents to be a little more hidden than others.
Okay. What's your ideal vacation?
Going up to the lake with the family, doing some swimming, fishing, boating, and just relaxing.
As an environmental engineer, what are some everyday practices you try to follow that may seem unusual or out of the ordinary for the average person?
Maybe this isn't considered out of the ordinary, but almost anything I do, I really try to improve the efficiency of how I do it, whether it's household chores or other things. I would say what is maybe unusual or out of the ordinary are some of the, I guess what I would call MacGyver-y solutions to certain problems that I might come up with.
As an engineer, I'm sure that skill comes in handy. What are you most passionate about?
My family.
So we have now an opportunity for you to give closing remarks that you'd like our listeners to take away from today. What would that be?
Well, I think, a great many in perhaps the general population think of the more macroscopic problems related to energy. Now, these are societal and even global problems. Those can be a little stressful to think about sometimes. And I think many of us in the energy sector probably boil down some reasonable amount of our job responsibilities as problem solving on a more microscopic scale. As an engineering consultant, I'm pretty much a professional problem solver. And again, for me, it ranges from figuring out if some new regulation applies to a client's facility to figuring out how to quantify air emissions from one of those really cool new types of generating or even manufacturing technologies. So we have our individual problems to solve, and all of our small solutions are ultimately, we're just trying to help us all where we're trying to go. We really just need to solve more problems than we create. So I think that is really my resounding message. Go out there and solve an energy problem. If you're an environmental or an energy sector engineer, I think you do that a lot in your job responsibilities. For other people, maybe it involves turning off the lights when you leave a room, making sure your tires are properly inflated to get the most out of your vehicle's fuel, or patching some leak in your hot water pipe. Just go out there and solve a problem and try not to create any more while you're doing it. But this macroscopic energy problem that I think a lot of people think about related to climate change, other pollution effects, that is oftentimes too big of a topic for individuals to really tackle on their own. So globally, regionally, locally, do what you can to contribute, and we will just keep pushing forward in this energy evolution.
Well, sensible words, no doubt, and certainly an important voice for the next generation of power engineers. So again, we really appreciate your time sharing this with us. So we need to check back in a year from now and see how things are developing in your front. So Tom Rolfson, thank you again, project manager for Power Engineers.
Thank you, Jason. Thank you, Energy Central, for having me on this podcast. It was a lot of fun, and I hope to talk to you again.
Fantastic. And you can always reach Tom through the Energy Central platform, where he welcomes your questions and comments. We also want to give a shout out of thanks to the podcast sponsor that made today's episode possible, to Power Engineers. Power Engineers is an engineering and environmental consulting firm specializing in integrated solutions for clients in the energy, manufacturing, and government industries. With mega trends like electrification and decarbonization transforming the grid, holistic solutions are needed now more than ever. And Power specializes in multidisciplinary teams that collaborate with clients from initial planning, feasibility and design through permitting and construction. Once again, I'm your host, Jason Price. Plug in and stay fully charged in the discussion by hopping into the community at energycentral.com. And we'll see you next time at the Energy Central Power Perspectives Podcast.